That is 6. This is this formula that plugs in. Get my calculator out. This one plugs in here, so that's 35, as well as this one's also 35. And eventually you get this equation. I'm going to go ahead and pull up alpha y equals 9.81 times 60 squared over 2 sine 35. Also times cosine 35. And I got 7.9. Oh, there it is. Get that.
Very good. Thank you very much. That's awesome. I appreciate
Hot
that.
dog.
So on this problem, we have our change in position, which we got from our question. We know that the 35 degrees, and also it's here. And then we know our gravity, we're going to use 9.8. It's either going to be a negative or a positive, depending on what's happening with the gravity. And we're just looking for a velocity initial. That's all we're doing. So to be able to do that, we're just going to use the formula that we have for that, plug it in, and boom, we have it. Everybody good?
Yes, ma'am.
Okay, so let's go ahead in our textbook on page 101. Let's look at question number 1. So on question number 1, it says measurements were made in 1910 indicating that a common flea is an expensive jumper gives its size. Assuming that the flea's initial speed is 2.2 meters per second and it leaps at an angle of 21 with respect to horizontal, if the jump lasts 0.616 seconds, what is the magnitude of the flea's horizontal displacement and how high does the flea jump? So, what do we have?
An angle of 21.
Okay. What else we got?
Change in T of 0.16. Yeah.
The initial speed.
And what did you say the angle was?
21 degrees.
Okay. And what else we have?
The initial speed, which is 2.2 meters per second.
Is that change in time?
I gotta turn my page. That's why I'm so lost. I'm like, where am I? What am I doing? Okay.
Would that be velocity?
Yes, maybe it would. Okay, so velocity initial is 2.2 meters per second. Angle is 21. And our change in time is 16 seconds. What does our formula look like?
I did 2 times sine of the angle times cosine of the angle times velocity squared over gravity. Because I figured gravity had something to do with it.
Oh. Backwards. There's my dyslexia. What are we looking for?
The change of x.
Change of x, okay? Change of x. What's our formula? VI, cosine, angle, change in time, correct? Is that the formula that you used?
I took the formula that we used on the sample.
Yes, ma'am, you did.
I just had to rework it to get the change of x.
My question is, did you get that?
Yes, ma'am.
Yep. You did it the hard way, but you can do it the hard way or the easy way, it doesn't matter. So if we do this, because we're looking for change in position, we want to see the cricket, right? velocity initial, which is our 2.2, cosigning our angle, which is 21, and then our change in time, which is 0.16 seconds. I want you to put it in your calculator on your computer to see. So you're just going to put it straight in. Remember, you have to make sure that you have it in the setting of degree, because if you do not, it will not do it correctly, because it's an angle. We're going to practice using our calculator today. Bless you.
Thank you.
You want to do another problem?
Yes, sir. If you've already got that one, go ahead and start working on number 2.
I feel pretty proud of myself that I did the whole thing.
Yeah.
Did anybody do the maximum height reached?
No.
Because I do believe, some strange reason, I did it. So let's see. What is the flea displacement and how high does the flea jump?
Wait, do we need to do that now?
Vertical displacement, yep. So how many questions do we have here? 2. All right, let's see if we can do the second one now. So we're looking for change in y now, aren't we? We're going to see how high he's jumped. Okay. There's you some help. So it says velocity initial, sine the angle, change over time over 2, plus half of the acceleration of y times the change in time divided by 2 squared. And when you get your answer, please call me. Find this one. I have something. I wish I had something else for you. I don't have anything here. This is what you did. 2.2 meters per second, sine 21. 0 times 16 divided by 2 plus 1/2 times 9.8 times 0 times 16, can't even read my own writing, divided by 2 squared.
Does that 9.81 have to be negative?
Nope,
It doesn't?
I didn't. Have we got an answer?
Is it right?
I'm not gonna tell you. After you get that answer, what do you have to do? Subtract. What am I subtracting? My answer from what answer? Yep. And I changed mine to scientific notation when I did it because it's just big numbers. Make it easier for me.
Oh, you got big numbers? Oh, no. Where did you get that?
That is your goal. Come on.
Hmm.
It's like,
All right. I forgot parentheses and it changed my answer.
it always does. And remember how they were talking about how you could use it back in the original formula where you had your equals and you could check your answer? It would have told you it was wrong. All right, listen, I'm not giving you brain cells, so I'll let you just digest that later. Okay, we're gonna erase this because I know you don't want to see this anymore. So now what we're going to do is we're going to go into the final one of this chapter, so that we can get through this, so you can start looking at your test.
So we're not gonna do number 2?
Mm-mm.
I did it.
Good, what'd you get? I got 2.44 meters high.
I got like 6.7.
6.73, yes. Yes.
And then for the how high was the fence? I got
Uh-huh.
like 25 point.
I had 24.4.
Okay,
Fantastic.
let's go.
Hands to you today. Okay, so what I was talking about in the last section is talking about the point of reference or where you're looking at when you're looking at an object. So it gave an example of an airplane. You could be above the airplane, and as you see it, it's going in a straight line. But the person from the ground looks at the airplane is going down. And that's what it's talking about there, is just giving you a frame of reference. Now, what was the important fact that you needed to know beside the frame of reference in this reading assignment from last night? What else beside the frame of reference?
On that, all those B of SC of
Yes.
LE,
Yes.
that thing, whatever, that was confusing.
So what they're doing is they're doing velocity, and they gave us an example of a fast car and a slow car, right? And it was saying like velocity of the fast car compared to the slow car, or velocity of the slow car compared to the fast car. That's all it is. It's the way that you're specifying what is interacting with what. Okay, that's it. So I looked at it and I was like, what the heck? But then after that, I realized it. They did give us a sample problem, so we're going to go to that one. So on the sample problem, it is on page, God bless us, 104. We're going to give him a little time to look at it, to get ready. I'm going to write it on the board for you, and when I get done writing it on the board, sir, you're going to come up here and talk.
Come on,
Page 104. You got this?
I got it written down.
Fantastic. It looks intimidating, but it's easy. All right, sir, come on up here and amaze us. I am ready.
Oh. Okay. Let me turn page 3. Oh, I'm playing. All right. Let's look at the given. 30.0 kilometers slash H. Yeah. You gotta have it right.
I know, I changed it.
And velocity, what's that? MB.
Okay, so the velocity of the water on the bank, do you
On the
see it right
bank.
there? And then the velocity of the motorboat on the bank. That's WB and MB. There you go, sir.
Okay, so we're looking for this and the angle.
Correct, we're looking for the motorboat compared to the water.
Water, and then we're looking for the angle.
Correct.
Alright. So we'll just go ahead and plug in the given. So,
Yes.
Yeah, so we're gonna plug in 30.0 here, and then we're gonna add that
18.0 squared.
18.0 square.
We're gonna square root it.
Square root it. Okay. Yeah, what she said. And we'll plug it back into this problem here.
Mhm.
Correct?
Correct.
And you're gonna get 35.0 kilometers and then an angle of 59 degrees.
Very good, thank you. Appreciate it. So if we look at this and we're looking at what we're trying to do here, we have the velocity of the water on the boat, we have the velocity on the motor on the bank. And now what we're looking for is we're looking for the velocity of the motor on the water. So we're going to square root the velocity, the two givens that we have. And we're going to square root it because we're trying to get the variable by itself. And then, of course, we're going to square it. Once you plug your numbers in from up there, and remember, you're adding in between, you should get 35. Did everybody in the class got 35? And then the only thing you got to do then is you take your 30, which is your velocity on the water in the bank, and divide it. You do tangent, -1 over 18. You get 59-degree angle.
Kind of similar to another thing we done, problem we did like that with the tangent.
I think it was velocity.
Yeah.
Yes, very good. Yeah. And we're doing velocity again. It's coming back, but this time it's a little different. How is this one different than what we did before? As far as velocity.
Velocity, it's got like the water and bank thing on it, like the
Multiple objects.
object. Yes, ma'am.
We only had one before, now we got two. Perfect. Okay, everybody feel good, comfortable so far? All right, we're gonna do question number 1 together. Okay, so what I want you to do is I want you to read it and write down your formula. Or your variables, excuse me. And then we'll write down the formula and figure it out. Now, my variables might be different than yours, and it's okay, as long as it makes sense to you. I used we and PW. Okay.
Are we plugging it in the calculator just like it is?
Yep.
Okay.
Is it okay if I switched it?
What did you switch, baby?
Like put 300 and a 450.
Oh,
Yeah, I thought about doing that too, but I was like, I didn't know. It mess up the
it
problem.
should change it though.
Yeah, you should change it at the end if you just plug it up like that.
Because my answer is
150.
1.50 times 10 to the second kilometers per hour. And then down here, it's 1.7 hours is what I got.
Yeah, mine's different.
You see, when I plugged it in the calculator, it gave me 150, but I mean, yeah, that's right.
Yes, sir, it is.
1.5,
150 is
yeah.
1.5 times 10 to the second power.
Yes, ma'am.
So if you plugged it in, either way, you're gonna still get 150, except you're gonna have a negative or a positive number. Is that what you're saying, Hayden?
Ma'am?
Is that what you're saying? No matter which way you put it, you're gonna get 150?
Yes, ma'am.
So what is our answer? Does it matter? Bailey, does it matter? It sure doesn't. Praise God. Because when we're looking at it, it doesn't matter which velocity we do first. This one or that one, it doesn't matter. We're still doing the total velocity, aren't we?
Yes, ma'am.
How comfortable do you feel?
I feel when I've got everything.
Would you like to do one more?
Yes, ma'am. I think.
I would like to do one
I
more.
would. Yes, ma'am.
But I'm going to skip to number 3 because there's a special thing about number 3. Number 2 is the same thing as number 1, but number 3 is special. So we're going to do question number 3, please. So question number 3 says, California sea lions can swim as fast as 40 kilometers per hour. Suppose a sea lion begins to chase a fish at this speed when the fish is at 60 meters away. The fish, of course, does not wait and swims away at a speed of 16.0 kilometers per hour. How long would it take for the sea lion to catch the fish? Where is your wow? How is this different? Our answers are going to be in seconds. That is our wow difference. Okay? So go ahead and start.
Why are they going to be in seconds? Because it's kilometers?
Mm-hmm.
But number 1.
Kilometers per hour, and I want you to change the seconds though, because I'm gonna add you an extra thing. You have to do a conversion if you don't mind. But you're exactly right. It doesn't have to be, but I want it to be. And the reason why I'm doing this for is because there's a question on the test that's going to ask you to do a conversion, and I want to make sure you have a practice. And sea lions are great, and I love them. Does it matter if we put direction?
I believe so.
Yes. Remember, change in time is always meters per second. Instead of kilometers per hour. Time has to be in seconds. So this is the velocity of this, the beautiful thing, on the water, and then the velocity of the fish on the water. And we're trying to find the position of the chain, sea lion and the fish. So the velocity of the sea lion on the fish is the same thing as the velocity of the sea lion on the water plus the fish on the water. And that's how we find the sea lion to the fish. Okay? I'm just letting you know how I use my little letters.
Ew.
And after you get that done, I want you to do the change in position because you have the answer for changing the position.
Goodness
And
gracious.
you're going to divide that by the velocity of the sea lion on the fish. And you're going to change that to seconds, please, for your change in time. And if you can do this, you're ready for the test.
I'm ready for this. Not fully, but I mean, you know,
You are.
we get there.
You're getting there.
You exit out of that calculator. It messes everything.
I know. So what is our velocity of our sea lion on the fish?
up. 56.
Yeah, that's what I got. So,
Subtract. Let's subtract.
Oh.
I did
Am
the
I
wrong.
supposed to be?
Yes, I did the wrong sign. I'm sorry.
Oh, man.
So
Well, you know-
24.
It is 24 kilometers per hour. I'm so sorry. 24.0 kilometers per hour toward the fish. And so we have 60 meters over 24.0 kilometers per hour. We got to do a conversion. 1 hour equals 3,600 seconds. 3,600? Yeah, I think so. 3,600? Yeah, there it goes. And 10 over 3 meters are in 1 kilometer.
How many kilometers in a mile?
10 to the third mile in 1 kilometer.
Oh, you got 1 hour and all that.
Yeah, I gotta take the hours per kilometer and change it to seconds. So if I do that, then my kilometers, meters, hours. So the only thing I have left is seconds. But do I have that flipped? I think I have that flipped, don't I? Because the kilometers are down here, kilometers have to be up there, don't they? Oh, Lord, happy son, telling you. You choose which one.
I think I already had that on there.
I'm gonna tell you the second one because the first one, they don't cancel out correctly. So I did the math wrong, so my number's wrong. So I'm gonna take this off because that's not true, because I'm not canceling out if I do it that way. Because kilometers are down here, they have to be up there. Meters is down here and it has to be here. Now, the question that I have for myself, is there 10 to the third kilometers in a meter, or is there 1 kilometer in a, which one is it?
Question. Do you have to plug in that all of that?
Yes,
Or can you just do that and then add that extra, like, convert, like you,
well, you can do it in separate steps. But here's the question that I'm asking you. Is that true now,
No, I'm doing it based
or
on-
is this true?
I think it's for the second one.
I'm almost there.
I'm pretty sure.
I'm getting there. Okay, which one is it? The green one or the pink one?
Green one.
Uh,
Well, that's the only one that's on campus.
No, I mean, it was the same thing. It's just I used the 10 and the 3 on the top and the bottom differently.
Mhm.
Okay, what answer did you get?
Got
You have to plug it all up in the calculator like that?
All up in the calculator like that.
Alright.
So, here you go, Hayden. Go all the way across, baby. Are you listening to me?
Cross. Yes, ma'am.
So 60 times 1 times 10 to the third power. And go down to the bottom. 24 times 360 times 1.
yeah,
What'd you get?
6.94. So every font like that, we have to convert.
Only if it's time.
Or it's good.
Yeah, you can do minutes per second, but I'm asking you to go just a little further. That's all. And just do minutes. All right. Y'all ready for the test? I'm ready to give it to you. Oh,
Alright,
let's
what'd y'all get?
take a breath.
6.94.
Actually, nothing.
Third.